guys, let's do section 1 notes. Atoms, elements, and compounds. Essential questions. What are atoms? How are the particles that make up atoms diagrammed? What are the similarities between covalent and ionic bonds? And how are van der Waals forces described? Here's the vocab that you should have already written down somewhere in your notebook. If you haven't done that, take a moment, pause the video, write your vocab, then come back. Let's just dive right in. Atoms. The structure of an atom. Atoms are the building blocks of matter. Everything that you see, taste, touch, hear, smell, all of it are made up of atoms. Atoms are made up of 3 smaller particles called neutrons, protons, and electrons. Protons have a positive charge, neutrons have no charge, and electrons have a negative charge. The structure of an atom. Protons and neutrons are located at the center of the atom, called the nucleus, and electrons are found outside that nucleus. There are different terms to describe the area where electrons are found. They can be called levels, shells, electron cloud. They all mean the same thing. They are found outside the nucleus in this region here. Okay? Elements. An element is a pure substance that cannot be broken down into other substances by physical or chemical means. There are over 100 known elements. 92 of them occur naturally in nature on Earth. Other ones have been created in a lab by scientists, but they are only around for a very short time. They have a very small lifespan before they break down into something smaller. Each element has a unique name and symbol that can be found on the periodic table. There are absolutely no repeats of names and symbols, so there is no confusion. If I'm talking about the element with the symbol F, I mean fluorine, and everybody knows that I mean fluorine, not another element. If I'm talking about H, I'm talking about hydrogen. If I'm talking about He, I'm talking about helium. So, each element has a unique symbol and name on the periodic table. Sometimes the names don't really make sense with the symbols. Like, let's see, lead is Pb. Pb. That doesn't have anything to do with the word lead, but it does trace back to the Latin name of lead. Sometimes scientists used those rather than the English words to create the symbols. Here is the periodic table. The horizontal rows are called periods, and the vertical columns are called groups. They can also be called families. I use the term family a lot more often than group because people in a family have similar characteristics. So in my family, I have the same color hair as my dad and my Aunt Linda. I also have the same nose as my dad. I have similar characteristics as my family members. We all have similar traits. So I prefer the term family rather than group, but you can use either one. Isotopes. Atoms of the same element have the same number of protons and electrons, but sometimes they have a different number of neutrons, and when that happens, they are called isotopes. Here we have the 3 isotopes of carbon. We have carbon-12 with 6 protons and 6 neutrons. We have carbon-13 with 6 protons but 7 neutrons, and carbon-14 with 6 protons and 8 neutrons. You'll notice that each one of these still has 6 protons. The only difference is the number of neutrons in the nucleus. Radioactive isotopes. Changing the number of neutrons in the atom does not affect its charge, but it does affect its stability. When a nucleus breaks apart, it gives off radiation that can be detected and used for many different applications. Isotopes that give off radiation are called radioactive isotopes, so when one of those neutrons breaks down, it gives off particles, smaller pieces, and that is referred to as radiation. This radiation can be used in lots of things. If it's in uranium, it can be used for a bomb, a uranium bomb. Hopefully we don't use those for a very, 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 very long time. They can also be used in a nuclear reactor to generate electricity. They can be used in medicine to diagnose and treat certain illnesses. So radioactivity, radioactive isotopes are very important in society today. A compound, switching gears a little bit, a compound is a pure substance formed when 2 different elements combine. So water would be a compound because it has 2 hydrogen atoms and 1 oxygen atom. Compounds are always formed in a very specific ratio. Water is always 2 hydrogen to 1 oxygen. If I change that ratio of 2 hydrogen to 1 oxygen, say I change it to 2 hydrogen to 2 oxygen, I no longer have water, I now have hydrogen peroxide, which has very different properties. I drink water. I don't want to drink hydrogen peroxide because it can kill me if I drink too much of it. Compounds cannot be broken down into simpler compounds or elements by physical means, but they can be broken down by chemical means, meaning you have to break the bonds that hold those atoms together. That makes it a chemical reaction. Now, you might be wondering, Ferris, why is hydrogen peroxide in a brown bottle? Well, it is because the light that gets in the bottle could cause that chemical reaction to occur that would break it down into water and oxygen gas. So, it comes in a brown bottle, and generally we store it in a dark place like a medicine cabinet, so that the light doesn't cause it to break down. Chemical bonds. The forces that hold substances together are called chemical bonds. The electrons of an atom are responsible for forming those chemical bonds. The nucleus has absolutely nothing to do with it. Electrons travel around the nucleus of an atom in areas called energy levels. You can see that with the shading on the diagram on the right. The darker areas are where electrons are more likely to be found. Atoms become more stable by losing or gaining electrons by attracting them or getting rid of them. Now there are 2 different ways, and the ways that they get rid of them determine what kind of bond they form. Atoms want to have a full outer layer, and they will do whatever it takes to get that full outer layer. Whether they have an outer layer with like 1 or 2, it's easy to get rid of those 2 electrons. But if they have an outer layer with 7, it's easier to take 1 from another atom. So they'll do whatever it takes to fill up that outer layer. Covalent bonds get that full outer layer by sharing electrons. Okay, that is a chemical bond that forms when electrons are shared, and they form a molecule. A molecule is a compound in which the atoms are held together by covalent bonds, and those covalent bonds form when the atoms share electrons. This is a water molecule. We have a hydrogen, and an oxygen. The oxygen is sharing a pair of electrons here and here. Okay? And that gives oxygen a full outer layer with 8 electrons. And this hydrogen a full outer layer with 2. Hydrogen can only hold 2 electrons, whereas most other elements can have 8 in their outer shell. Hopefully you remember that from chemistry last year. We don't have time to go into the specifics, but just know that a covalent bond is when they are shared. Ionic bonds are the opposite, when electrons are completely transferred from one atom to another. An atom that has gained or lost an electron is known as an ion, and they carry an electric charge, meaning they are either more positive or more negative than the atom that hadn't gained or lost an electron. An ionic bond is an electrical attraction between 2 oppositely charged atoms. So here we have a sodium ion that is giving an electron to the chlorine. And this gives each one a full outer layer. This sodium has lost an electron. It has lost a negative entity, so it has become positive. The chlorine has gained an electron, so it has become negative because it has gained a negative charge. So the positive of this sodium attracts the negative of the chlorine, and they form an ionic bond. All right, that is the attraction between the positive and negative ions. Some atoms tend to donate or accept electrons more easily than other atoms. Metals usually will get rid of electrons. They'll donate one to a nonmetal, which tend to accept electrons. Most ionic compounds dissolve in water and are crystalline at room temperature and have a very high melting point, especially when compared to covalently bonded atoms. So these would be like table salt. Table salt will dissolve in water. Van der Waals forces. These are attractions between molecules. When molecules come close together, the attractive forces between slightly positive and slightly negative regions pull on the molecules and hold them together. The strength of the attraction depends upon the size of the molecule, its shape, and its ability to attract electrons. So lots of things come into play there. The slightly positive and slightly negative charges around the water molecule are attracted to the opposite charges of other nearby water molecules. Van der Waals forces are responsible for water droplet formation and surface tension. The van der Waals forces between water molecules have a specific name. They are known as hydrogen bonds. And hopefully you learned about those in chem last year. Once again, we don't have time to go into the specifics. This is just a broad overview. So that's it. Hopefully you have been able to fill out your notes. If you have any questions, let me know, guys. Email me or ask me in class.